Hello Calc 2 students. In section 11.8 on power series, we are mostly focusing on finding the radius of convergence and the interval convergence of various power series. So I have a few examples I'd like to go over. For my first one, we have the sum from n equals 1 to infinity of the term n squared, x to the n, all divided by a product 2 times 4 times 6 times up to 2n. I wanted to go over this because that product on the bottom is a little bit strange. You work with it the same way you might work with a factorial by leaving it all written out. But notice, because we are not multiplying together each integer from 2 up to 2n, this is not actually a factorial. To find the interval of convergence, we want to know which values of x make this series converge. The ratio test is our go-to method. The ratio test says that a series, a sub n, converges if the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n is less than 1. What we want to do is figure out which values of x make that limit less than 1. So for our series, a sub n is this expression. So if I look at the absolute value of a sub n plus 1 divided by a sub n, I'm first going to write a sub n plus 1. So I have n plus 1 squared times x to the power n plus 1 divided by this product 2 times 4 times 6 times times 2n times 2n plus 1. Now I need to divide by a sub n, which is the same as multiplying by the reciprocal of a sub n. So I'm going to write the numerator n squared x to the n, the numerator of a sub n in the denominator now, and this strange product 2 times 4 times 6 up to 2n on the top. We want to simplify as much of this as we can. I'm going to collect like factors. So we have n plus 1 squared on the top, and we have n squared on the bottom. We also have x to the power n plus 1 on the top, and x to the n on the bottom. And then we have these strange products, 2 times 4 times 6 up to 2n on the top, and 2 times 4 times 6 2n times 2n plus 2 on the bottom. And now we can simplify. So I can write this first fraction as n plus 1 divided by n quantity squared. In the second fraction, we just have x. In this third fraction with the strange products, we can cancel the 2's, we can cancel the 4's, we can cancel the 6's, and so on and so forth. We can cancel the 2n's. So we end up with just 2n plus 2 on the bottom. Now, what else can we do? The fraction n plus 1 divided by n, I can divide each term by n, get 1 over 1 plus n squared. The fraction 1 over 2n plus 2, I'm just copying, and then I have my x. And the last thing I want to point out is that the absolute values here only need to surround the x, because the n's are already positive. Now as n approaches infinity, the fraction 1 over n goes to 0, and this fraction, 1 over 2n plus 2, goes to 0. Altogether, as n approaches infinity, we get 1 plus 0 squared times 0 times the absolute value of x, which is 0. Now the question is, for which values of x is this limit less than 1? Well, 0 is less than 1 for all values of x. So our conclusion is that our radius of convergence is infinity, and our interval of convergence is the interval from negative infinity to positive infinity.